Hello everyone and welcome to Makeover Monday week 14 Watch Me Viz. I think I may be having a bit of trouble with my audio today, so if somebody could please let me know if you can hear me, that would be great, and then I will proceed. But if you can't hear me, then I guess you won't be able to respond. Can everybody hear me? Okay, great. Thank you. Appreciate you telling me that. It looked weird on my end, so appreciate that. Okay, so we're looking at a really interesting data set this week. I picked it on purpose because I thought it would be a bit tougher for folks. It's yeah, so this data set, it doesn't have any dimensions or really it's only got one, sorry, it's got one dimension, but it doesn't have any time series, it doesn't have any location data. It's simply a really analytical type of data set where you're looking for relationships in the data. So yeah, let's first go off and take a look at the original visualization. So let me open this in a new tab. This image is within the research report, which I didn't pay to get access to, but I do know that this is from inside of the article, and it's a simple bar chart, and I'm suspecting that so we could see each of the bars represents, it looks like they each have some kind of acronym, and then we have the different bean varieties on the side. The y-axis looks like it's a rate that it exists. So the MLP, for example, exists 89.56% of the time, and the Barbunya bean type. So a couple things here. I think those percentages are over precise. I don't think we need 89.56, but again, this is a research paper, so sometimes that is important. We would need to look that up in the data set itself. This type of bar chart is useful if you want to compare within the different bean varieties. So for example, I can see that the orange bar in Barbunya is SVM, and that's the tallest. I'd be tempted to sort the bars within each of the bean varieties so that we can see where each of the colored bars ranks. That's about it for the visualization itself. This is where I got the data set from. It's from the UCI machine learning repository. And one thing to note here is that we have all of these different attributes. So these give you a nice little description for what each of the measurements means. So for example, area is the area of the bean and the number of pixels within its boundaries. Okay, there are 7 different beans used in the research, and it looks at form, shape, type, and structure. Okay, so they ended up with a total of 16 features, 12 dimensions, and 4 shape forms. So the shape forms, this must be the shape factor 1, 2, 3, and 4. I don't quite understand what those mean because there's not really any more information about that. When I look at the text file itself, the one that came with the data set, it really just says the same thing here. It just says 4 shape forms. So yeah, I'm not quite sure what we can make of those. I'll take a look at them, but I'm not sure I can do anything with them. And then the research paper is here. It doesn't really tell you a whole lot about the paper. It just says it's a machine learning technique, and it was classified with an accuracy of 93.13%. So I believe what they did is they first recorded data about beans, and then they used a computer model to determine if they could measure these properties using machine learning without actually measuring the bean themselves, so letting AI do it, basically. Okay, so let's go ahead and start with the data set. And we can see I added this bean ID field, so this wasn't in the original data set, but I wanted everybody to know that these were different beans. And we have all of those measures that were in the that are in this text file that get mentioned. So again, if we see shape factor 1, 2, 3, and 4, when I look at the data set, I just see these kind of numbers. I'm not really sure what these mean because I don't see any more definition about those. So I think what what's going to need to happen there then is I'm probably going to have to ignore those because I can't make any assumptions about those. I suspect that they are defined inside of this paper, but we can't see that. So we can see these, let's see. Yeah, it doesn't even see, even looking at the table of contents, we'd have to download the article and pay for it in order to be able to determine that. And even if we look at the tables, we can't actually see any of them. So if I look at the figures, I don't believe so. We can see some images here, but they're not particularly helpful. So I'm going to probably just ignore these 4 columns. So I'm going to highlight the 4 of those, and then I'm just going to hide them. That way I don't use them by accident. And I'm going to set the default aggregation for all of the measures to an average in case I want to look at the beans in aggregate, or if I want to look at all of the beans by class, something like that. So let's go to sheet 1, and I'm just going to go ahead and select all of my measures, and then change the default aggregation to an average. So now I can look at the class, I can look at the average area, for example, and if I wanted to put bean ID on detail, I could see each of the bean measurements. You see each line here, but it gets a bit hard to see. So I think what I'll do is I'm going to put the random function in here, and I'm going to jitter them. And now if I set it to entire view, I can see a bit more where the area of the beans, so it's a bit more spread out amongst the Bombay, and the Barbunion is, so let's put an average line here for, let's see, we want to do it for each pane. Oh, wrong direction. So average line for each pane for the area. There we go. And so this kind of helps us determine how many are above or below. What does it look like if I make it a density? So you can see here they're a lot more compact here. I could also maybe add in, let's see. Yeah, I think that's okay. This actually doesn't look too bad. Maybe I'll change them to circles. There we go. So now we can see the different beans spread out by the different classes. So this is the area of the beans. And if we sort them by the average, so let's sort by the field, descending average area. There we go. So now we can see they go from, you can see the average lines go lower. But we can also see that they also have a smaller distribution as you go left to right. So if I add in, for example, let's see, if I do a distribution band for each pane, and I want to do it to, let's see, percent the standard. So let's go 1 standard deviation around the sample. I'm going to turn my labels off, turn my tooltips off, untick my recalculate, maybe make this a bit lighter gray. So actually, let me make this a bit darker gray because it's hard to see. Let me make this a bit darker because it's hard to see behind these other ones. I'm not going to leave it like that, but you can see that the bands get smaller and smaller as well. So there's fewer outliers within the other species, or yeah, the other species of beans. Are they called varieties of beans, not species? So yeah, so this would be my jitter plot, and I could, change, allow us to swap out the measure. I think maybe to do that, I'm going to create a parameter. Oops, not a calculated field. I'm going to create a parameter, and I'm going to call this my, let's see, select a measure. And I'm going to need to populate it with a string. And I can't add values from there. So what I'm going to do is I'm going to go back to this, and let me just copy this. I'm going to kind of create like a spreadsheet almost. So area, okay. This is just going to take a second. So perimeter, major axis length, minor axis length. This is, unfortunately, I'm only going to have to do this once, so if I want to use it again, I can. Eccentricity. Actually, an easier way to do this might be, let me just hit OK. If I put measured names and measured values, okay, then copy cross tab. And now if I paste that in here, there we go. That's quicker. Eccentricity. Okay. And what was the other one? Equivalent diameter. Okay. So now what I can do is, well, first off, I'm going to rename this field equivalent. And now if I edit my parameter, I can paste from my clipboard and I get all my values in there. Okay, it's classifier accuracy. Okay, thanks. Let's hit OK. So quick question from Parth Patel. How did the average random pill separate the points? So the random function always gives you a value between 1 and 0, and it's just assigning a random number to each of these, to each circle. So it's not, I don't know, it just spreads the dots out between 0 and 1, and that's it. And then the height is relative to the area in this case. Okay, so now that I have that, I'm going to create a calculated field, and I'm going to call it measure value. And so now I can say case, and this will be select a measure, oops, when that, oh God, it's so annoying when Tableau does that. This just takes a minute to go through all the different options. Okay. Is it aspect ration or ratio? What should it be? Aspect ratio, so it should be ratio, so I'll change that. Okay. Then area, aspect ratio, then compactness, then convex area, then eccentricity, then diameter. Oops. Okay. All right, so let's hit OK, and then I'm going to rename this one to aspect ratio. And then let me edit this, and this one should be aspect ratio. All right, so now if I show my, let me go back here, and I'm going to show my parameter, and I'm going to set my measure value to be an average. So let's put the average on there, and now let me make this a single value list. So now we can see how it changes through each of these. So I would want to change my sort. Instead of it being based off of, I think I set it to the average of area, I want it to be the average of my measure value. So then it always goes down. Okay. Great. All right. All right. Solidity. Okay. So very good. Okay, and EK said on here that each measurement you see here is the classification. sorry, the yeah, these represent the classification accuracy, I guess, or these are the measurements actually. So, okay, what else could we do? We could look at maybe for each class, we want to look at the average of the value. Let's show the parameter. Let's flip that around and sort and aspect ratio, compactness, convex area. So something like that. So these all have a pretty large, let me see here. I'm thinking of maybe doing like a small multiples layout, like a trellis chart, but these all have very large values. So if I was going to do a small multiples, what I would need to do is represent each of these as a percentage of the largest number, which that's going to be quite the chore. Let's see. So I think so. What I was thinking was, can I have a series of boxes that show, how each of these is relative to the other. So if I create a calculated field, and I'm going to call it relative area, I'd want to say the average area minus the min of the average area, and wrap that, and then wrap this in an average, like that, and then wrap that whole thing in brackets, and then divide it by the max minus the min. So let me copy that. I think this will work. And then that needs to be wrapped in brackets as well. Okay, oops. So edits. I have a contains, cannot be, okay, what did I do here? So oh, this should just be min area, not min average area. But that's not going to be correct. So, right, so let me start over here. So we're going to take the average of the, I'm just doing it for the area, right? Or actually I could do, all right, let me try this again. So I'm going to take the average of the measure value, and then I want to look at the minimum. But if I just do something like min area or measure value, for example, that's going to only return the, yeah, so I need to do that minus the window min of the average measure value. There we go. So this is going to look at the range in the data, and then divided by the window max of the average measure value minus the window min of the average measure value. Okay, and then I'm missing another bracket. All right, so if I put that on here, then what did I call that? Let's see. I want to call this relative. I'll just call this relative value. And if I put that here instead, I should get the same shape, but we can see it's now showing us a percentage. So this means since Bombay is the largest, it gets assigned 100%. And Barbunya is 40%. So I've got something wrong there. Because that's not 40%. So that, it should be like 60%. So I got something wrong here in my calculation. So I want to take the value. Oh, no, I want to do this the other way around. Window max average value. I think this is how I want to do it, minus the average value. Nope, that's wrong as well. Undo. What the heck am I doing wrong here? Sorry, I'm going to cheat here and bring up some of my calculations. Let me see. Where is this? Let's see. Okay. Place with video on all calculating. So Ravathi, it'd be impossible to create a video on all calculations in Tableau. Yeah, I want to show it relative to the min. So I think so that's relative to the min, but this needs to be, what I'm trying to do is I want to show that one relative to that one. So that would be the value for that compared to, what if I just did, what if I just did divided by, would that do it? There we go. That's the shape I'm looking for. But now this is wrong because I'm getting 2.26 here. I'm getting the same shape, but I want it, so I want it to be that, and then I want to divide it by, yeah, I think I had it right. Okay, so edit table calc. Yes, that's not going to do it. What am I doing wrong here? So this is taking the max minus the min, so that's the entire range. And then this is taking the value minus the min. So I think I've got it the other way around. Value divided by window max. So what I'm trying to do here, what I'm trying to do is I'm trying to, well, it's kind of hard to explain. I'm trying to create the relative difference in the measures or across the class. That way, if I change the measure, it's all just still relative to 100%. Okay, let me try that. Okay, there we go. Great. Okay, thank you. Thank you for that. Vaibhav, sorry, I'm not quite sure how to pronounce your name. Okay, so the beauty of this now is when I change the aspect ratio, you can see each of the values changes. So if I put, let's see, so I'm just going to put the class on color just so we can see what happens. And let me change this to a single value list. So for example, let's just highlight Bombay, for example. So area and aspect ratio, you can see it moving. And my thinking was, could we create a small multiples view for each of these different metrics? But I think what's happened, I think I would need to reshape the data. Okay, so let me duplicate this data source, and I'm going to edit the copy. And what I need to do is I'm going to flip. I need to, let's see, well, let me get rid of this one. Delete. Yes. And then I'm going to grab all of these and I'm going to pivot. Okay. That's going to make a table really tall. I hope I didn't just crash Tableau. Okay. Oh boy, here we go. So this is our measure name. This would be measure value. Okay. So let me go to a new sheet, and I should be able to, let me now copy this field. So let's copy that and paste. No, go here and paste. I'm just going to put class on here for now. Measure value. Okay, so this needs to be, okay, that's, so I don't need that. So let's get rid of that. And then if I edit this and I make it, so look at that, isn't that pretty cool how it does that in average calculation, whatever. So I'm just going to make that measure value and measure value. So if I now put this onto the view and measure name onto the columns, you see they all go from 0 to 1 now, which is what I was looking for. So what was the one we looked at here? So if we look at, for example, let's look at area. Just turn the labels on. So we should get 43.54 or 0.4354 for Cali. Cali is 0.4354. Perfect. Okay, that's great. That's what I was hoping for. So now I'm going to create a trellis chart. So I'm just going to copy my calculations. And I'm going to just save these over here. So I just have these in my notes and I just save them. I do have a video on how to create the trellis chart. So the relative value, all right, so let me flip the chart. Okay, and I want to move, let's see, so columns and rows both need to be discrete. I want to put columns in the columns, row in the rows, class on detail, and then I need to compute using class and compute using class. Oh wait, I did that backwards, I think. Measure name needs to move here. Okay, compute using, so it needs to be for each class measure name. So compute using measure name. Okay, there we go. So now we have each of the different, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And how many measures do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, great. So now we have a nice little small multiple layout of, let's get rid of the border. Yeah, for each of the, right. So the problem now is I can't sort them. So that's not very helpful, is it? So let me put class on color. You see the colors are going to repeat as we go across. But I can't sort them now. So that's not particularly helpful. Okay, well, that was a loss. So I'm going to color that red because it didn't do me any good. Okay, so let me go back here, and I'm going to now just start comparing a bunch of metrics. So I'm going to highlight all of these and put them here in the columns. And I'm going to highlight all of them again and duplicate them into the rows. I should just see a bunch of circles. And I'm going to put B90 onto detail. And basically, I'm just trying to see if there's any patterns across all of the, I'm comparing every metric to every other metric. So, but it's trying to draw a lot of marks, so this may have been a bad idea. Okay, so while that's going, there's a couple other ideas. So let me go to Twitter, because there was an idea that somebody had given me. Let me see if I can find it. Oh boy, everything's running slow now. So let's go to notifications. Okay. Okay, this is still, okay, here we go. So we have all of our, okay, it's going to be impossible to look at all of these at the same time. And you can see we've got all these straight lines because those are where I'm measuring compactness versus compactness, for example, right here. So that's not going to be very useful. So I'm going to clear that because it's also slowing my entire computer down. But there was a, come on. Why is this going so slow? There we go. So there was, oh boy. Also, when I live stream, it tends to go slow as well. All right, so while that's running, another, of course, another option that we could look at is a ternary chart. So let me go to my, how can I find this? So Andy, Creable, Tableau, Public, Penguin. Okay. Interesting that something in Japanese comes up first. Okay, so this is a type of chart that allows you to measure 3 different metrics at the same time. So what we could maybe do is allow the user to pick the 3 metrics they want to see on the corners, and it helps you kind of understand the direction that the values lean. So I think the Flairledge twins. So Flairledge, they have a blog on how to understand these. Let's see. And while that's running, let me see if I can find the other viz that I was thinking of. Wow, everything's going like crazy slow. Okay, see here you see somebody did the jitter plot. And here's one with all of the values in the view, but that was just drawing way too slow for me. So, okay, so I need to find this. All right, why is that still? I know I'm jumping back and forth, but I'm trying to let things kind of load. Okay, this is really frustrating how slow the live stream makes my computer. Come on. Is this it here? No, that's not it. All right. I just want to make sure I give the person credit, and I need to find it again before I can give them credit. So, okay, no, that's not it. I could have sworn it was before that. Yeah. It was kind of like it was sort of like a bump chart. Come on. Sorry, I'm quite positive this is really boring. Okay, no, that's not it. That's not it. Okay, well, I can't find it now. But here's there's a visualization here, or a good explanation of what okay, here we go. So when you create a ternary chart, you basically end up with, you have 3, you have a measure on each corner, and depending the direction that the dots move, or the values move within it, you can see which way they're weighted, or if they're balanced, if they're more towards the middle. So you see it kind of creates 4 triangles, almost like you can think of it like a quadrant chart. Okay, so I am quite annoyed that I can't find this. Isn't there a way? Let me look on my phone, because I know I replied on there. It might be quicker, because then I can just share the, I I can just pull up the tab. So bear with me for a second. Come on. Okay. Now everything's going slow. Right, because I can always just open it. As long as I find it, I can just find the person on Twitter. I think it would be useful for you to see what I'm trying to replicate. Ta-da. Okay, here we go. Okay, so let me go. That's fine. Okay. Okay. Boy, this is like crazy slow. So I don't think I can open this in a new window either, can I? Let me see if I can. No, it's not going to do anything different. Okay, so this is like this is kind of like a bump chart. If it comes up again, shoot. Yeah, so basically it did, so this is Takafumi. So they did a ranking, so you can see each of the measures going down the side, and then the rank of each of the beans going left to right. So to build something like that, it would be easier, I think, to use this flipped data set, because if I put the class here, I put the measure value there. Let's see, so this is going to be, so we've got each of the measures going down, and then each bean going across. Okay, so let's make this an average. And then if I put measure name here, what am I doing wrong? Does it need to go like that? Why am I messing this up? Quick table calc, rank. Okay, so that's good. What does this look like? So we just have one, so that's the rank 1 through 7. That's good. And then we have the area. Okay, let's put that on detail. Make them circles. Ah, there we go. And then I need to edit the table calc again. So this is going to be for each measure name. Okay, there we go. So now if I put this on color, I can see, so if I highlight one of them, you can see how it connects. Okay, so I want to make this also a line and connect by path. Let's see, connect by measure name. Let's see, so if I go Bombay, okay, that's right. Okay. Ignore the colors for now. So let's duplicate that and make these circles. And that's a line, and then we would make it a dual axis and synchronize. Okay, so now this is, I'm going to flip it though, because I find a bump chart much easier to read going left to right. And I'm going to flip my axis. So I'm going to reverse it so that 1 is at the top. So the best one is at the top. And then if you if you highlight them, you can see where the different classes rank amongst each of the different measures. So prepping the data or pivoting the data makes this one much easier. And what you could do on here is I could put the label on there, and let's align them center and center. What I would probably do here, though, is maybe have a parameter that allows you to highlight a class, or you could, if I move this to just detail, and then I show the highlighter, you can hover over and you can see where that one ranks compared to the others. So this is just the built-in highlighter, or you could use a parameter to do it that way. So that's one way to do it. And then the other way is to do the relative values like I was thinking of before. So this is our bump chart. So like a parallel coordinates chart. So let me duplicate this sheet. I don't really need to duplicate it, but I will anyway. And let me get rid of that. Okay, so my relative values, this was the, yeah. So let's put that here instead. And I want to edit my table calc, and I want to do it for each measure. Okay, so this is now telling me, if I go back to where was my trellis here, so you can see all these values are very similar. Yeah, so this is where it's not, so that's 100%. Yeah, so this calculation isn't right. So let me find a, let me just find a parallel coordinates. Okay, and okay, I'm just going to open this up because I think this will help me get the calculations right. Because a parallel coordinates chart is supposed to show the relative change. Okay, so the smallest value should be at 0, and the largest value should be at 1, and then everything else is relative. Yeah, so the calculation is definitely wrong. A curvy bump chart, yeah, you can do a curvy bump chart, but you know, if you want to spend the time. Okay, so let me go to this sheet here, and I'm just going to double check how I built the calculations. So let me just go this one. Yeah, so it's okay. So let me just copy that. And okay, so this should be measure value, measure value, measure value, oops, and then measure value. Yeah, this is what I was doing earlier, but these should all be averages. Okay, and there we go. So now it's working right. Okay, so this is just an alternative to a bump chart. So this is called a parallel coordinates. Because it shows the relative differences between the values. So now if I choose the different class, there we go. So I can see where it ranks relative to the others. So what's this one, Bombay? Its minor axis length and major axis length are much higher than all of the others. So hopefully you understand what I mean by a parallel coordinates chart then. Again, it's just looking at the relative difference between the values. So it gives you, it acts just like a bump chart, except it spreads the lines out a bit more because you're comparing the value for every individual mark compared to the maximum within that. So within solidity, for example, if I just highlight solidity, we can see, let me put measure values on detail. We could see that this should be average. Okay, so we can see the, let me look at a better example here then. What's wrong there? Okay. So what this is saying is you've got the solidity here that is 71 or 72% of the value for the solidity for, I guess it's Seeker. Dermicin is 72% the solidity of Seeker. So if I go back to here, my trellis, you can see, oh, this is going to be hard for me to find the right one. Solidity, so Seeker compared to, which one? This one here. Dermicin is 72%, so it's 72% of the value. If I put just measure value on here, okay, that's not going to help me very much. Let me put measure name, and let's just look at, sorry, I'm going to keep this as an example so you have it later. Let me go here again. Let's put measure name. I just want to explain a bit better what the bump chart is doing. So we've got the class, and we've got the measure value, and let's make this an average. Okay, so if I sort them descending order, so you see Seeker has a value of 99%, or 0.99, Dermicin is 0.988, so the relative difference between them, even though they're very close in value, the relative difference is 72%. So Dermicin is 72% of the value of Seeker when you scale them. Hopefully that makes sense. Okay, so where was I here? Okay, so the next one we can look at is maybe the ternary chart. So what we need to do here is we're going to essentially build out kind of a triangle like this. So we're going to allow, okay, let me see. I think I have one. Here we go. So you see this one has 3 different measures on the corners. So I'm going to first allow somebody to pick each of the measures. So let me go back to my, okay, so let me edit this, and I'm going to say select the top measure, and then duplicate. I'm going to call this one bottom left. Maybe select bottom left, or I'm going to just rename it bottom left. And then this one would be just bottom right. Okay, so we have, oh yeah, so I need to go back over to this data set, and I have measure value. So let me just duplicate that, and I'm going to call this one the top. And then I'm going to duplicate that and call this one my bottom right. So instead of this being my top parameter, this is going to be my bottom right parameter. And then duplicate that and call this one bottom left. Okay, so let's show all 3 of these parameters. And I'm going to make sure they're all different values. So let me do single value list, single value list, single value list. Okay, they didn't all fit. That's okay. So let's do area and aspect ratio and compactness, something like that. So now that I have those built, I need to, I'm going to again cheat and look at some of my calculations. So I need to build a bunch of calculations. Let me start with just those for the top and the bottom. Okay, so let's create a new calculated field. All right, and then everywhere this says metric, I want to replace it with, let's see, so let's start with the top. Okay, and then top, top. Oh wait, no, that's wrong. Sorry, I did that wrong. So this should be What am I doing wrong here? Yeah, no, that's correct. And then, yeah, let's see, I want my, sorry, this should be my top, and then this should be my bottom left. Sorry, I'm getting myself confused here. I think I'm doing this right now. Bottom left, and then this should be bottom right, bottom right, and bottom right. Okay. Okay, and then this should be top. Oh, what happened there? Oh, top. Top. Okay, so now I can drag all those over. I've got an error message, that's okay, I can fix that. Okay, so let's delete that. I think I just have it extra here. Yeah, there we go. Okay. So once I have those, so I'm just basically just bringing back the value for, this is doing something, if I open up this calculation, this is, oops, sorry, wrong one. If I open up this calculation, it's basically the same thing as the parallel coordinates calculation that I did. So I'm taking the value, subtracting the minimum, and then dividing it by the max minus the minimum. So I'm just, again, getting that range of values. That's all it's doing. And then I need to have an X and a Y. So I need to create another calculated field. And this should be bottom right value, top value. Okay. And this is telling us how to draw the triangle. All right, so let's close that. And then both of these, oops, I'm going to default these to an average. Okay, so X is going to columns, Y is going to go on the rows, and I'm going to put my bean ID onto detail, add all members, and we can see we start getting something that looks like a triangle. Okay, I can even put maybe the class on color just to help us split it up a bit. Maybe I'll make them a bit smaller and I'll make them circles. Okay, something like that. So now you see everything goes from, the scales need to go from 0 to 1 on both sides. So I'm going to set this to go from maybe minus 0.0, let's see, 0.01 to 1.01. And then same thing here, edit axis. I'm just going to set these to be the same, so minus 0.01, 1.01. And now I need to get a triangle in the background, so that's where I've drawn some triangles. I have a PowerPoint template that allows me to draw, or that I've drawn triangles that I can use as a background image. So I'm going to go up to, let's see, I'm on the dry beans data set. I'm going to add an image. I'm just going to call this my triangle. And let me see here. So triangle, let's maybe do a gray triangle. And my left, so this is where the 0 to 1, this is where you need the 0 to 1 in here. Hit OK. And there we go. So now I can see how each of these skews. So let's get rid of the border and get rid of the halo. Okay, there we go. So now I can see the skewness of each of these, of each bean measurement. So if I change this now to, let's say, I want to look at, let's say, area versus the major axis versus the minor axis. And we can see everything is kind of on the bottom there. So what that means, if I go back to this, where is the, here we go. So you can see it's balanced, but it's kind of weighted more towards, instead of it being weighted more towards the area, which is the top, it's weighted more towards the major and minor axis. So we could look at maybe compactness and convex area. Okay, that's not very interesting. So, and so on. So roundness, maybe roundness versus compactness versus diameter, something. Okay, there we go. So they all lean more toward the roundness. So I think I kind of like the view of this. So why don't we just go with this, because it's already an hour in and we need to get going here. So let me just go ahead and format the view. Okay, and I'm going to get rid of my grid lines. And I'm going to get rid of my axis rulers. And okay, so I want to hide my headers. And I'm going to not include those in the tooltip. And when I hover over, I want to get my three values. So bottom left, bottom right, and top. I'm not using the ones that say value because those are the ones that give me the relative scale, but I want to have the actual value. So, and then what I can do is, so bean ID, and then I could say, so the class, let's see, that's fine, class, and then instead of the saying bottom left, I'm going to insert my parameter, and then here I'm going to say insert my top, and then insert my bottom right, and to me the logic makes better if I go top, left, and then right. So now you hover over, I can see that for that particular bean, it's in that class. The compactness is 0.82, diameter is 272, etc. So the diameter is the bottom left. So you can see the, yeah, so I think I like the view of that. I'm not sure I like the color, so I might make that a highlighter instead. So let's create a new parameter, and let's call it highlight class. So string, it's going to be a list. We're going to add from class. Okay. So let's call this class highlight. All right, and for this one, I want to say that the class equals the highlight, my parameter, or the highlight class equals none. Okay, so I need to add a none value, so I forgot to add that in here. I want to add a value of none. That way the user can choose to not highlight anything. Okay, so let me switch these. So let's make that compact. Compact list. Compact list. Let's get hide. Okay, so now let's do highlight. Let's see, where's my highlighter? Class highlight. So I want that on detail. Class highlight on color. Okay, I want the trues always in front of the falses. Okay, let me pick some colors here. So I'm going to go to my Makeover Monday palette. My trues, maybe I'll make that. And then maybe I'll make my falses like a light gray. Maybe something like that. And make those stand out. And then maybe I put the class highlight on size as well. And then I'm going to reverse the sizes. And then let me make this small as small as it'll go and make the largest one a bit smaller. Okay, something like that. And then I'm going to reduce the opacity. Okay. Right, so we got something like that. I think that's okay. And so this would be my ternary. And now let's go ahead and put this into a dashboard. So I'm going to delete the mobile layout. How do I want this to look? So I'm going to have a title. I want to have across the view. So let me show that parameter. Oh, so now I'll show you if I change this to none, they should all go gray, which is what I want. Okay. So we don't need to, we can hide that. And we can hide that. Okay, so let's build a dashboard. So I'm going to float in this. I'm going to play around with the size later. So 0, 0, 1,800. Okay, so I'm going to start with my title, or just a text box. And I'm just going to call this my title. Or I could say, what is this called? Multiclass classification of dry beans. And then I'm going to insert my parameters. So that versus the left versus the right. Okay, and I'm going to put a blank in here. Okay, I'm going to put now my chart in here, and that's going to bring in all of these boxes back here. So let me hide the title, and then I'm going to go to here, and I'm going to float that container. Remove, delete. Okay, so what I want to do now is I'm going to have these go left to right across the view. So let me hide the view toolbar, and let me now put in a text box at the bottom. Okay, so I want to grab the citation, which is, where's the citation? I think it's in here, right? Citation request acknowledgements. So let me just copy that in. And paste that in. Okay. And I'm going to actually put a container in here, put that in that container. And I'm going to have another text box here. And this is going to be designed by okay, and that's fine. Okay, good enough. Let me change the colors here. Okay. And I'm going to add a bit of a buffer on the bottom of this one, so okay, just trying to give it a bit of space. All right, so now that I have that, what I'm going to do is I'm going to put a horizontal container in here, and I'm going to move each of these into that container. Okay, so let me select that container. I'm going to put maybe something like that. What does that look like? Okay. All right, and then I think each of these, so top measure. I think I'm going to get rid of the word select. Okay. And then highlight class. Highlight a bean class. Okay, let's make sure that works. I can choose none. Okay. So now this whole thing might look better if I make the whole dashboard, so dashboard format. If I make the whole thing dark, and then this sheet, let's format the sheet. And let's say the shading is transparent. Okay. So now I just need to change this text to be maybe gray. And I need to format that background to be that. Maybe I'll go one lighter for that. Okay. So let's format this guy and edit the height. So it's 58. Let's maybe make it 70. Okay. And then I think what I'm going to do is instead of having this with 20 all around, I'm going to make a 10 all around. And I'm going to put another blank here. Edit the height, make it 10. And then set the background of this to also be that white. Or no, I think I went with the gray. Yeah, there we go. So now we kind of have that section sort of boxed out. And then each of these, I'm going to set the okay. All right, so I think that looks okay. I might not need this to be 10. That probably could be 0. Okay, so now if they pick a different metric, so let's say that I'm going to look at the extent versus the perimeter versus the solidity, something like that. And they can highlight a bean class. There we go. So now the question is, can I find one that's really nicely in the middle? Convex area and perimeter. Nope. Okay. I just want to find one that looks nice for kind of publishing it up the Tableau Public. So did I look at, so if I look at major axis length, minor axis length, okay. I think this needs a bit more transparency as well. So let's make this maybe 25%. Okay, how's that look? So, all right, so now the whole dashboard I think is a bit too wide. So I'm going to make it 900. Okay, so I think that's a bit better. Okay, what do you think? What do you think of that? Any thoughts? I'd love to hear your opinions on that. You can see this isn't quite, so if I undo the axis, let's undo that. You see it doesn't quite fill up the space the way I'd like, but that's fine, it's good enough. What I could do here is I'm going to just show the two headers. So sometimes, you know, when you put something into dashboard, it kind of is going to throw the view off a bit. So I'm going to maybe make this go from maybe 0.0001 to 1. So 3 zeros. So edit axis. So minus 0. Okay, and now I can hide the headers. Okay, that's better. So maybe that might be a bit too much. You see, you just end up getting pretty fiddly with this. So let me make it just 1. I don't think I'm making much difference here. Probably none at all. Very little. Okay. So there we go. So then maybe I'll put a bit of inner padding on this. So maybe like, there we go. Okay, I like that better. So any questions? Looks really good. Thank you, EK. Yeah, so I think I might make these a bit more gray to match kind of the gray around the outside of these, of my triangle. So maybe if I make that a bit darker, I think that's good. Let's make that there. Okay. All right, I think I'm happy with that. I'm gonna, before I publish it, our drop down's not a bit too light background color. Yeah, I don't think I can control the background color of that, because that makes the whole thing, that does the background of the whole image. Let me see if I can format this. Yeah, see, I can't, well, format parameters, here we go. So the shading, yeah, see, that shades the whole thing, which is a bit annoying, so I don't really have control over that, unfortunately. So let's pin the height of that. We pin that. Okay. All right. So I think I'm pretty happy with that. What does it look like if I go just 800 by 800? I think I like it better like that. All right. It reminds you of Pink Floyd. Good point. Before I publish this, I'm going to just play around with different metrics and find one that kind of, you know, I like the look of for publication. I will post a link to both the Flairledge's blog, and I'll post a link to one I did before. And then there's also Adam McCann. He has one, Game of Thrones. Yeah, so this is where the idea originally came from. This is from Korea. which is interesting. Why does it keep putting me in a different place? Let's see if that does anything. I don't know why it keeps like changing the region. Okay, so if we look at, yeah, so the original inspiration came from this Game of Thrones viz by Adam McCann, which I think looks absolutely amazing. Okay, so thank you very much for tuning in. Does anybody have any last questions before I jump off? And I know I'm looking to the side, but that's because I'm looking at my screen. Any questions? I'll give you a few seconds to type them in here because I know there's a delay in the chat. Okay, I guess there's no questions, which is fine. And again, thanks for joining. All right, you have a wonderful week. And the weather's getting a bit nicer here in the UK. It's going to be cold this week, but hopefully it gets warmer. Enjoy spring. It looks like it's here. And I will chat with you all next week. Bye.